A car's position s of t in meters is modeled by the function s of t equals 3t squared plus 2t plus 5, where t is time in seconds. Find the velocity, find the acceleration. If you're given s of t, and that's the position function, which is what we're given here, okay, this is from the section called rectilinear motion. Okay, what you do is if you take the derivative gives you the velocity at a specific time whenever you plug in t. The second derivative is going to give you acceleration at that specific time. I don't even know how to spell acceleration, so look at that. I'm going to cheat. So A is asking me to find the velocity at t equals 4. That requires me to find the derivative of s. So the velocity function s prime of t is going to use the power rule. The derivative of 3t squared is 6t. The derivative of 2t is 2, and the derivative of 5 is nothing. Okay, at 4, we say s prime of 4 is going to equal 6, replace t with 4, plus 2. Okay, 24 plus 2 is 26. Now, since we have time in seconds and we have meters, our rate is going to be 26 meters per second. Okay, and so that's going to be the rate, meters per second. Now, the second derivative is going to give us our acceleration at time t. So s double prime of t is going to be the derivative of s single prime of t. The derivative of 6t is 6. The derivative of 2 is nothing. So when I quote-unquote plug in 4, quote-unquote, there's no t to plug it into, and I still get 6. So this is not 6 meters per second. This is 6 meters per second, or per second squared, because you took the derivative again. Okay, so you do that. Is basically, you know how you have, d squared y, d dx squared. Same idea. You are taking the d dx squared of everything by taking the second derivative. So these are my guys, and yeah, that's how you find velocity and acceleration. A particle moves along a line so that its position at any time t, as long as it's a positive t, because you can't go back in time, is given by this wacky function right here, where s is measured in meters and t is measured in seconds. If you are given a position function, okay, this is called rectilinear motion. If you are given a that's positive, nope, I can keep going, position, I nailed it. The first derivative gives you velocity. The second derivative gives you acceleration. So the first problem is find the instantaneous velocity at any time t. That's just asking what the first derivative is. Okay, so s prime of t is going to be using the power rule and taking the derivative of each and every term up here. The derivative of negative t cubed is negative 3t squared. The derivative of 7t squared is 14t. The derivative of negative 16t is negative 16, and the derivative of 8 is nothing. So that is my instantaneous velocity function at any time t. Nothing to plug in, we're done. B is asking us to find the acceleration at any time t. Similar idea, we're going to take the second derivative, which is the derivative of the first derivative. So we're going to use the power rule a couple times again. The derivative of negative 3t squared is going to be negative 6t. The derivative of 14t is 14, and the derivative of negative 16 is nothing. So that's my acceleration function at any time t. Now, using common sense, the particle is at rest means it's not moving. Okay, so the particle is at rest when your velocity is 0. So let's go back to our velocity function and see what happens when the velocity is 0. Okay, so I'm going to, this is going to be awful. I'm going to set this guy equal to 0 and rip out a negative. So I have 3t squared minus 14t plus 16 and see if I can factor that guy out. Let me see. One of them's got to be 3t minus 8 minus 2. 3t squared minus 6t minus, yeah, that'll work. Oh, how about that? Okay, so that equals 0. Okay. What I need to do is I have two factors here. Okay, the obvious factor is going to be t equals 0, so that's good news. The other one I'm going to set equal to 0 and solve, so 3t minus 8 equals 0 has me adding 8 to both sides, 3t equals 8, divide by 3, t equals 8 over 3. Okay, so one of the things I actually have to really be careful of is if I were to get a negative one of these, that's not possible because t can't be negative. Both of these were positive, so that makes me happy. So the times that these are at rest are actually realistic, legitimate times. And that happens at 2 seconds and 8/3 of a second. Okay, there you have it. Now, displacement of the particle for the first 3 seconds, what does that mean? Well, that just means where is your guy after 3 seconds? Where does it travel? The way you do that is if you were to have like an interval, in our case, interval is from 0 to 3. If I label you A and B, I am finding S of B minus S of A. In other words, where am I at 3 seconds? Where am I at 0 seconds? Subtract the one from the other. Okay, so let's find out what S of B, which is S of 3, is. S of 3 is going to be negative 3 cubed plus 7/3 squared minus 16/3 plus 8. So that's going to be 27. Let's attach a negative to it. 9 times, so that's 9 times 7, which is going to be plus 63 minus 48 plus 8 is going to equal negative 4. So this particle is like 4 feet underground, whatever that means. S of, did I do? Okay, so no, that's not where it starts, though. That's where it ends up. Ooh, close one. S of 0 is going to be much friendlier. S of 0 is going to be 0 plus 0 plus 0 plus 8, which is 8. So I start 8 feet in the air, whatever that means. I end 4 feet underground, which means my total displacement where I am now, or where I started at the beginning to where I am now, is going to be a distance of 12 meters traveled. Ooh. So yeah, lots going on here, but yeah, we did it. I had fun doing it too. I hope you did. A particle moves along the x-axis so that at time t, its position is given by x of t equals t cubed minus 6t squared plus 9t plus 11, where t is measured in seconds and x is measured in feet. All right, so you have this guy moving along the x-axis, okay? Now, this is its position. This is where it is on the x-axis left to right. Which means, looking at this problem, we were talking about velocity, we're talking about maybe acceleration, but let's at least, I see the word velocity, let's try to understand what velocity means in this context, because I see that phrase right there. Okay, the derivative is velocity. Now, a negative velocity is real. I mean, I know in the real world, if I were to, drive backwards 10 miles an hour, I wouldn't say that, oh, I'm going negative 10 miles an hour, but that's actually what we're doing. All right, so here, a negative velocity would mean going left. So if this is negative, that would mean we're going left. If this is positive, that would mean we're going right. So what I want to do with this first guy is at t equals 0, is the particle moving right or left? I need to take the derivative, okay, and see where I'm at when t equals 0. So that's going to be x prime of t equals, power rule a bunch of times, 3t squared minus 12t plus 9. Okay. This is very simple because I'm plugging in 0, so x prime of 0 is going to be 0 minus 0 plus 9, right? And that's going to be a positive 9. So a positive 9 means at this moment I am going positive 9 feet per second. So since it's positive, that indicates that I'm going right. So I'm going right because I have a positive velocity at t equals 0. So that's me explaining without having to explain too much because I don't feel like it. At t equals 1, is the velocity of the particle increasing or decreasing? Now this is very, very, very similar to what we just did, because if I were to take the derivative again, that would give us acceleration. Now acceleration is you speeding up or slowing down. Okay, so if I were to, at a specific point, and at this point 1, if I were to get something that's negative, that means at the moment I'm slowing down. Okay, if I were to get something positive, that means I'm speeding up at that moment, right? I know those words aren't being used here. And this is asking if the velocity is increasing or decreasing. That's the same thing. If I'm driving, right, and my miles per hour goes from 10 to 12 to 14, that's me accelerating. So this is the same idea. So what I need to do is I need to take the derivative of u, so it's going to be power rule again a couple times, and then plug in 1 and see what happens. So if I take the derivative of x prime of t, that gets me the second derivative. Power rule is going to give me 3t squared becomes 6 regular t, minus 12t becomes minus 12, and then plus 9 disappears. I care about what happens at t equals 1. So x double prime of 1 is going to be 6 times 1 minus 12, which is 6 minus 12, which is negative 6. So that negative 6 indicates that I'm slowing down. So my velocity is decreasing because I have a negative acceleration. Okay? And that would be why. So what else? Find all values of t for the particle that's moving left. All right, so again, this goes back to the moving left problem. This goes back to problem A. So problem A, what I have is I care about when it's moving left, and that's going to involve me finding out all the intervals where I have a negative velocity. So let's take this guy. Okay, now when you have a particle moving left or right, you care about the negative velocity, which means we care about when velocity changes. So what I have to do is find out when the velocity is completely 0, and that'll indicate where my velocity changes. So what I do is I set u equal to 0, and I'm going to factor that equation out. First thing I can do is I can pull out a 3. That's going to make life easier. T squared minus 4t plus 3. And that's going to allow me to factor out to 0 equals 3, t minus 1, t minus 3, which means my magic numbers are going to be 1 and 3. 1 and 3 are my critical points, which means 1 and 3 is where the velocity is 0. That means I'm stopped at that moment. So I'm expecting this guy to move from like right to left to right. But how do I know that? Well, let's make ourselves a sign table for x prime of t, right, of t, and my zeros are 1 and 3. I know it's moving left if at any moment I plug in a number into the derivative and get a negative number. I know it's moving right if I plug in any point into the derivative and get a positive number. So what I'm going to do is I'm going to pick negative, 100, and in my mind plug it in. Actually, you know what? No. I already did that. I'm just going to plug in 0 because I wasn't thinking there. So I'm going to plug in 0. I'll plug in 2, and I'll plug in positive 100 to see what I get. I know from part A that when I plug in 0 into the derivative, I got a positive velocity. So you are positive up here. So you're not moving left, you're moving right. If I plug in 2 into the derivative, I would get 3 times 4, which is 12, minus 24 plus 9, which is a negative number. If I were to plug in 100, I would get 3 times like a really huge number minus like 1200 plus 9. That's going to stay positive. Okay, so that's my sign table. According to my sign table, I am negative between 1 and 3, which means I'm moving left between 1 and 3. So the values of t, where this particle is moving left, is going to be t is in between 1 and 3. Including 1 and 3? No, because at 1 you're stopped, and at 3 you're stopped. So this is me writing it out in inequality notation. You could use the parentheses 1 comma parentheses 3. Whatever works. In between 1 second and 3 seconds is when we are, seconds, right? Yes, seconds is when we are moving to the left. Okay, so that is C. Last but not least, we got displacement. Displacement is where you are now at the moment, not how your distance traveled. Where are you, according to Blink-182? Get it? Miss You? It's a lyric in Miss You. I also said to the left. It made me think of Cupid Shuffle, but I didn't sing that. How do I find displacement? Well, my original position function is x of t, so my displacement is found by taking where you are now, 6 seconds, and subtracting where you were at the beginning. So I need to find x of 6, and I need to find x of 0. So x of 6 is going to be 6 cubed minus 6 times 6 squared plus 9 times 6 plus 11. This is actually super convenient because 6 cubed minus 6 times 6 squared is also 6 cubed, so you completely go away. And you become 54 plus 11, which is 65. X of 0 is going to be 0, 0, 0, 0, 0, 0, 11. So my displacement is going to be, I'm now at 65 feet to the right. I'm subtracting 11 feet to the right, which means I went from 11 to 55, and that is a change of, why am I struggling, 54 feet? So there you have it, 54 feet. So very involved problem, but we covered a lot of things here in this problem. I enjoyed it. It was fun. If the position of an ant traveling along a horizontal path at time t is 3t squared plus 1, what is the ant's average velocity from t equals 1 to t equals 6? I know what you're thinking. Take the derivative. Nope, 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 nope. Average velocity means average rate of change. So we're going to use the average rate of change formula, f of b minus f of a over b minus a. U would be my a, u would be my b. So finding f of b is me finding f of 6. And that would be 3, 6 squared plus 1. 6 squared is 36. 3 times 36 is 108. 108 plus 1 is 109. So that's f of b. F of a is a lot friendlier. I'm just plugging in 1. So that's going to be 3 times 1 squared plus 1. 3 times 1 squared is 3 times 1, which is 3 plus 1 is 4. So when I plug this all in, I get f of b, which is 109, minus f of a, which is 4, over b, which is 6, minus a, which is 1. That becomes 105 over 5. And that's a big fat 21. And that's going to be my guy. Like and subscribe. The position of an object moving along a straight line is given to you by the function s of t equals 5t to the fourth minus 16t cubed plus 8t squared, where s is measured in meters and t is in seconds. Find the velocity function. Well, the velocity function involves me just taking the derivative of the position function, and that's it. Not plugging in anything, that's it. So the velocity function is going to be s prime of t equals power rule, power rule, power rule. So drop down that 4, 20t to the third, drop down that 3, 48t squared, drop down that 2, 16t, and that's my velocity function. No harm, no foul. Easy peasy lemon squeezy. B is what is the object's acceleration at t equals 2 seconds? Well, the acceleration function is you taking the derivative of the velocity function. And so I need to do that and then plug in 2. So s double prime of t is going to be power rule, power rule, power rule. Drop down the 3, 60t squared. Drop down the 2, 96 regular t. Get rid of the t, 16. Now I'm going to plug in 2 into that equation right there. So s double prime of 2 is going to equal 60 times 2 squared minus 96 times 2 plus 16, and we just have some ugly math. 60 times 4 minus, what is that, 192 plus 16. 240 minus 192 plus 16 is going to be 64. Now, do I have any units? Seconds, meters. So this is going to be meters per second squared. Okay, velocity would be meters per second. I didn't have to do that. But now I have meters per second squared. Okay, now the third question is going to be the grossest one of the three. At what time does the object change direction? Okay, now direction changes when velocity either goes from positive to negative or negative to positive. Okay, positive velocity in this case means you're going to the right. Negative velocity means you're going to the left. So if you were to go from right to left, that means you just changed direction. So I care about what we did in problem A and finding out where that happens. Now that's going to happen at a critical point. Okay, and in this case we might have 2 critical points, maybe even 3. So we need to find those critical points. So problem C involves me taking the velocity function and setting it equal to 0. So 0 is equal to 3t cubed minus 48t squared plus 16t. I have a 4 and a t in common with all of those, so let's rip that out. 4t, that's going to leave me with 5t squared minus 12t plus 4. So let's see if I can figure that out. So I'm going to have a 5t and a regular t. Those are my options. And positive 4 is going to be minus and minus. 2 and 2? Yep, that'll do it. So I have my 3 possibilities. And I'm going to be careful here, but all of them are going to work. 0 is going to be my first one. Okay. This one I'm going to set equal to 0, so 5t minus 2 equals 0. So if you add 2, you get that, and if you divide 5, you get that. And then t equals 2 is my other option. So I have 3 spots where at the very beginning, technically, you do have a direction change, so that kind of, I don't feel right saying at the beginning, but I'm going to say it anyway because it's a possibility, it's an option. Okay, it changes direction at 0, so I guess technically you're fine. But my seconds are going to be 0, 2/5, and 2 seconds. Of course, that's not in order, but who cares? Now, what you have to be careful of is what if any of these were negative? Well, if any of them are negative, then that's not an option because you can't have negative time. But yeah, that's what we're going to get here. So fun stuff. The position of an object moving along a horizontal line is given by s of t equals a third t cubed minus 3t squared plus 8t. Find all intervals where the object is speeding up. Now, the object speeding up means acceleration is positive. So I have the position function. The first derivative gives me the velocity. The second derivative is going to give me acceleration. So I need to go down to the second derivative here before I can do much anything. So let's take the first derivative. Okay, s prime of t is going to have power rule, power rule, power rule. So drop down the 3. A third of 3 is nothing. Well, 1, sorry. And that leaves me with t squared. Okay, drop down to 2, minus 6t, get rid of the t, plus 8. That's the first derivative. That's velocity. That's not what I want. Second derivative is going to be 2t minus 6, nothing else. Okay, so I care about when this is speeding up. So what I need to do is I need to find my inflection points and make a sine graph. My inflection points are where the second derivative equals 0. So 0 equals 2t minus 6. This is where you're going to have a change from speeding up to slowing down and where you have 0 acceleration. Okay, so I'm going to add 6. 6 equals 2t. Divide 2, t equals 3. So if I'm making a sign graph of the acceleration function, I have an inflection point at 3. What I do in order to find where it's speeding up is I care when the acceleration is positive. So I take a point greater or less than 3. So if I pick 0 and pick 100 and plug it into the acceleration function, this will allow me to find out where this is negative and where this is positive. So if I take 0 and plug it into the acceleration function, I get 0 minus 6, which is negative. That means I'm slowing down. That's not what I want. If I take 100 and plug that in, 2 times 100 is 200, 200 minus 6 is positive. So this is where I'm speeding up. Spup. So this is speeding up at time t is greater than 3. Do I not have a seconds? I don't know. It doesn't say anything. So at time t is greater than 3 is where I'm speeding up. Do I include 3? No, because at 3 it's 0, which means at 3 it's neither. Okay, so that's how you find where an object is speeding up. A ball is launched into the air from the ground with an initial velocity at 48 feet per second. The ball's height is given by the equation s of t equals negative 16t squared plus 48t feet per second. Find the velocity of the ball the instant it hits the ground. So first thing I need to do is find out when it hits the ground. Okay? So I'm going to take the position function and know that this has to do with height. I know this is a parabola that's going to look like this. Okay, I'm going to set this equal to 0 because that setting it equal to 0 means that I'm on the ground. Okay, my height is 0 and s of t represents the height here. So it hits the ground when s of t equals 0. That's my position function. So I have negative 16t squared plus 48t. Let's factor out negative 16 and t. So negative 16t. And that leaves us with t minus 3. Okay, so my two options for t is going to be 0 and positive 3. Now one of these is where it's launched and one of these is where it hits the ground. I'm no mathematician, but I know 0 is not going to be where it's launched. So this hits the ground at t equals 3 seconds. Cool. Am I done? No. Because I care about the ball's velocity, or is it a rocket? What, a ball. I care about its velocity the moment it hits the ground. So I need to take that position function right here and find the velocity function by taking the derivative. So s prime of t is going to equal the derivative of negative 16t squared, power rule is going to be negative 32t plus 48. Now I'm going to take that 3, because that's when it hits the ground, and plug it in. So negative 32 times 3 plus 48. Negative 32 times 3 is negative 96, plus 48 is going to be negative 48. Now what is, so feet per second. Why negative? Because it's going down, and the moment it hits the ground is 48 seconds. And this kind of makes sense, because if you launch it at 48, you're expecting the speed that it goes up to come down and hit the same speed the moment it hits the ground again. So the math seems to work out. Now, I know in the real world we have friction and stuff like that, and so that might take a factor, but not here, not in this make-believe problem that I created using ChatGPT. So there you have it. It's a lot of 4.2 stuff that we did. I hope you watched it all. And if you don't, go back and watch it all, like and subscribe.